here, and I'm here to talk about the scanning tunneling microscope. And it's a type of an electron microscope which uses a single atom tip to attain atomic resolution. And it's basically, a physical or a physics electricity way of getting to know the surface topography of any kind of material. So a brief history is it was founded in Switzerland at Zurich in 1981 by Gerd Winning and Heinrich Roher, who were then later rewarded with the Nobel Prize for Physics in 1986 because of their invention. And a general overview about that is an extremely fine conducting probe, and it's held at about an atom's diameter from the top of or the topography of the substance. So the electron tunnels between the surface and the tip to produce an electrical signal. So while you scan the total surface across, the tip is raised and lowered in order to keep the signal constant and maintain the distance. This enables it to follow the smallest details of the surface as it's scanning. So the tip is generally the size of an atom. And what we say is this is now quantum tunneling, as we are seeing here. And classically, when an object hits a potential that it doesn't have enough energy to pass, it will never go through that potential wall. It always bounces back. So it's kind of easy to put a lesser potential electron onto the surface topography to have it bounce back, and you can use it via a receiver, and then you can map a total surface. So these are the tunneling graphs, as you can see here right now. And quantum tunneling is, basically a bigger complex formulas. Now we'll go to the main thing. Okay, now small movements from the tip to get the distance between the tip and the sample down to a couple of angstroms, where the tunneling current is measurable. The STM uses feedback servo loops and converse piezoelectricity. So we'll talk about servos for a minute here. And now servos are small devices with a shaft that cannot be precisely controlled with electrical signals. In the valve timing trains of cars, real cars, which, in the modern days where the ECU is so prominent, the electrically controlled servos do the job of the inlet valve and the outlet valve. Example, the IV Tech system in your Honda petrol car. And we talk about converse piezoelectricity now. Piezoelectricity is the ability of certain crystals to produce voltage when a mechanical stress is applied to it. When you apply an electric field to a piezoelectric crystal, the crystal distorts. This produces an electricity which is known as converse piezoelectricity. The distortions of this piezo is usually in the order of micrometers, which is in the scale needed to keep the tip of the STM a couple of angstroms from the surface. Now we talk about another vibration isolation. The original STM design had the tunnel unit with the permanent magnets levitated on a superconducting lead bow. They used 20 liters of liquid helium per hour, which was, a little bit too expensive for a common procedure for the STM, which is so expensive. So what they did was, it was, like many other things currently, it was updated, and now STM have high precision optical components and disk drive to just trace the topography of a proper sample. Now it uses the variations in current, voltage, tip, surface and separation and their derivatives. The electronic properties of materials can be studied. So for an example, let's take a fullerene or a buckyball, as we call it, the C60. when you press down on a buckyball by 1/10th nanometer, it lowers the resistance of the buckyball by 100 times. So we can, reduce its distance, and also lower the resistance, which is a handy thing if you wanted to conduct electricity. So let's talk about the pros and cons of the STM. The pros is the scanning takes so fast because it's just an electric signal traveling over a topography. It can be so fast because it's just an electric signal traveling over a topography. It can basically finish a small size sample in a fraction of seconds. And the cons is the surface must not have huge cavities. You know what I'm saying? Because the tunneling needle has to go in and out, which is gonna take a lot of time, and it has a problem. Because the tunneling effect won't be so prominent if the depth is higher. And that's it for this video. Thank you very much.